Alright guys, thanks for turning up. My name's James and I'm going to be talking at some point during my presentation about ASReview, but I'm also just going to talk about some other things that aren't actually connected to it first. First up, I'd like to acknowledge that we are meeting on Indigenous land, and I'd like to acknowledge if there's any Indigenous people in the room or watching from afar. So, who am I? A question I've been asking myself for however old I am. I am actually a PhD student from IPI, so I have in the room Joseph Cherokee and Bajuna Sadra, my supervisors from my PhD, who trained and traumatized me. Since then I've moved on to the Centre of Research Excellence, Indigenous Health and Alcohol at Sydney University, and I'm finding my stress levels slowly reducing, which is nice, although it was too late to save my hair. Before I actually talk about what I've been asked to come and talk about, I'd just like to quickly go over the research we're doing there to give you a feel for what I do when I'm not here, and to give you a sense of object permanence. So, the broad topic of what our centre is interested in is alcohol. So alcohol, you may not know, is complicated stuff. It can be a lot of fun, but also causes a lot of harms. In particular, 3 million deaths per year across the world are directly attributed to harmful alcohol use. And alcohol can cause all kinds of difficulties for people. If you get really drunk, you can hospitalise yourself, get into a car. It can cause issues with pregnancy, chronic health conditions, so hypertension leading to stroke, or actually it's very strongly connected to cancer. And it also causes community problems, so trouble with police and issues with connecting to culture and to each other. So our group's interested in alcohol. And who's affected? Loads of people. Across the world, each year, every person over the age of 15 drinks on average 6.2 litres of pure alcohol, which equates to about 138 litres of beer every year for every person, which is an incredible amount of booze. And it's not just humans that are affected, bees actually can get all the grog. So some bees fly out, and actually, I saw in a documentary at some point, is my source, that bees tend to get hooked on alcohol at a similar rate that humans do. And what they'll do is they'll go out of the hive, they'll find fermented tree sap, drink it, get smashed, and then actually when they come back to the hive, there's bouncer bees that sting them to death to stop them getting inside the hive and causing problems. So it's an interspecial problem for beings. But it's also an issue for Indigenous peoples, which is what our centre is in particular interested in. So Indigenous Australians are actually less likely to drink at all. They're not very likely to be current drinkers. But when they do drink, they're more likely to be hospitalised on average in some communities. The second area our institute is interested in is supporting new Indigenous researchers to become independent and go on to ask their own questions. So we have 12 researchers across Australia connected to our centre who we support. And their research covers the entirety of Australia apart from Tasmania. And these include trainees, PhDs and master's students, and one early career researcher who's doing a lot of cool stuff. In terms of the research questions I've been involved at this centre, they fall into 4. So, firstly, how to measure drinking patterns in Indigenous peoples. Can we work out how much Indigenous Australians drink? How do we bring those patterns together? Can we increase screening rates with structured screening tools? And why do some people drink more than others? So firstly, how to measure drinking patterns. And I should say this research is being led by my manager. If this wasn't going on YouTube, I'd just claim all the credit, but it is. Kylie Lee, and also with an Indigenous elder, Scott Wilson from ADAC. So you might think a question like how do you drink is pretty simple, but actually it can mean many things. Your responses can be, you're actually asking many potential questions. So if someone says to you, I have about 3 drinks of wine per day, you might think that's great. 3 wine glasses, that's a bit much, but not too bad. But in the clinical work that some people at our institute does, what they actually mean by 3 drinks of wine is 3 sports bottles of wine, which is a totally different box of cheese. So to try and get around potential miscommunications around drinking, our group has created an iPad app, which allows people to actually, and I have an iPad here if anyone wants to see after the talk, allows people to exactly select what they drank and then what they drank out of it. So if you drank out of a soft drink bottle, you can just select that and then show how much alcohol you put in it. So it looks like that. So we've done quite a few studies on this app. We've shown that it's acceptable for use in Indigenous populations. It's valid. It's about as good as an interview with a trained health professional. But the question is then, how do we use this data we're getting from this app to integrate findings on drinking patterns? And that's actually quite a difficult thing to do, because you're often going to totally different parts of Australia. You're learning how much people drink. What's the take-home message? If I find one community drinks this much and another community drinks that much, have we learned anything? Can we synthesize that? So we did a meta-analysis that was published in Addiction earlier this year. And basically we went through and tried to find as much research reporting on Indigenous drinking patterns, looking at the percentage of current drinkers, percentage of short-term risk, percentage of long-term risk. We looked for continuum measures like average down drink per day, but found hardly any of it. And we just brought it all together to have a look at how it actually ties together. And what we've found is it doesn't tie together at all well. So you can see down here we've got the proportion of current drinkers. So everyone's a current drinker to no one's a current drinker. And if you follow the history of samples, of Indigenous samples over time, you can see it's basically random. So if you go into one community and you find that they drink 60% of them are at risk, then that doesn't actually tell you anything about another drinker. We did find a few moderators though, so guys are more likely to drink and come to harm than girls. This is out of order, but a lot of heterogeneity, almost 100%. And we also found that instrument is important. So it's not good enough just to say, oh, we asked how many people drunk. When people didn't report what instrument they used, they found on average 43% were current drinkers. And when people used structured screening tools, which there were many, they all converged on about 60%, which is kind of interesting. And we think this might potentially be due to a frame of reference effect, where if you ask someone, am I a drinker, that's really a question of identity, and they're going to make that identity assessment in reference to others. So if they're surrounded by a whole lot of boozy animals, then they're much more likely drinking their one wine glass a day. Oh, I'm not a drinker, they're drinkers. But if on the other hand they're surrounded by total saints that are totally abstinent, then suddenly that one wine a day might be identifying for them. So the take-home message I got from this is there's massive heterogeneity. Anything you find about one community does not necessarily apply to other communities, and perhaps this would mean that if you were going to do an intervention to try and help Indigenous communities, you should work with those local communities to do an assessment of what might be helpful, because they're likely to have a different strengths and challenges to other communities. So the next question, so the take-home. Learning about drinking patterns in one community may not tell you about others, which I just said, what's the point of slides? Can we increase screening rates? Okay, so it looks like structured screening tools like the audit is a popular one, might be helpful for determining screening risk. You don't want people just making a lot of random assessments of who's at risk, because maybe they're right, maybe they're wrong. It really depends on context. So to do this, we did a big cluster randomized trial. I say we because I did not set this up, but I got to analyze it, so I'm definitely claiming for more credit than I'm due by presenting this. But basically, we got 22 Aboriginal community-controlled health services, so the communities actually get to dictate how the services run across Australia. We randomised 11 to an early support who got support from our team. Basically, we told them to do the audit C, and 11 who were in a waitlist control. We compared them after a year's intervention. The support had literally everything under the sun in it. We gave service champions to the services to actually, it was their job to teach other people in the services about the audit scene, to really push it. We had a national workshop. We brought representatives from all these services to Sydney and gave them a 2-day workshop on using the audit C. We sent a clinician out to each of those services after this to give all of the workers in those services training, which was a horrible job for her. She got to see lots of wonderful places. We gave them resources so they could buy FASD dolls that show what it looks like for a baby who's been affected by alcohol, what that does to them. And they also got practice software support, so they all use software that manage clinical sessions, and then often the audit C is buried way down in that software, hard to find. So this support just helped to put it on the top screen. We also did data feedback, so every 2 months services got a PDF report showing how many people were drinking, how much screening is going on, how close they are to targets and stuff like that. They engaged in phone conferences every 2 months, and they had an online platform to communicate and download resources. So instantly you can see we've done too much. It's going to be impossible. If we find anything, it will be impossible to know what to find. So I approach rather than to isolate theoretically on one thing, we've isolated everything possible and just to see, does something work? And then if something does work, we can drill down on that later. The dataset came directly from their clinical practice software. So every 2 months, they send us these variables. So whether someone came during that 2-month period, whether they got the Odyssey done, a subjective assessment of alcohol risk, and then things like, did you give them medicine, did you do a brief intervention, what was their blood pressure, and how are their liver enzymes, so a whole host of data. Unfortunately for me, this came in separate Excel sheets for every single variable from every services every 2 months. So that's 242 Excel spreadsheets per 2-monthly period, which so far is equated to over 5,000, which need to be merged into a single data set, which of course we didn't do manually, we used R. Basically you have all these mystery spreadsheets, and they really are mysterious because spreadsheets will be labeled blood pressure and have liver enzymes inside them, so it's a real horrible job. What we did was we use R to look inside each sheet, identify the type of data it is, then we can identify what's what. Then it's just a matter of sorting it, and then you can merge it together into one big data set. And it is a big data set. Just in the 2-year study period, we've got 283,884 clinical observations, which has stuff like what screening done, what were the liver enzymes, what was their blood pressure, for 70,000 unique individuals, which equates roughly to 10% of Australia's Aboriginal population. So it's a cool data set, but kind of hectic. The data set's clustered, so you have multiple sessions under multiple clients for multiple services. We use multi-level logistic regression for it. We compare the baseline to the post after the support starts. We just want to see, has there been a difference? And what we found is that over the period, our control group actually increased naturally. At post, they had 5 times the screening that they had at baseline. The odds had increased 5 times. Our intervention group increased 25 times though, from baseline to post, which is a relative increase of 5 times, which sounds too good to be true, and it definitely is. So if we look at the actual plot, we can see that at our baseline, despite getting 22 different services and 10% of the Aboriginal population, and randomly allocating them stratified by remoteness, there was still a substantial difference between the 2 groups, which just speaks to the level of heterogeneity among services. By post, we got them to be much better. I mean, the absolute increase in screening percentages is kind of similar for both, but to take someone who's near zero, an odd near zero screening, to go up to pretty okay is a gigantic leap relative to okay screening to still pretty okay. So that's why we see such a gigantic effect for such an unimpressive plot, unfortunately. So you can see, again, these are all the different services and their screening rates changing over the period, and they couldn't be more spread out. It's like a game of pickup sticks. But you can see these are our early guys, our early support. You can see some were doing nothing, and afterwards they're jumping up, whereas it looks a bit more random for late support. So we think we got an effect, but with a big asterisk, loads of heterogeneity. Okay, finally, very quickly before I talk about something you came to listen to, why do some people drink more than others? To do this, we're using self-determination theory. We know that self-determination theory is incredibly important for well-being. If you don't feel autonomous, confident, and related to others, you're likely to feel pretty miserable. And the thing is, when people do feel miserable, they tend to compensate for feeling miserable by picking up behaviours that might make them feel good in the short term, but might ruin their health or social life in the long term. So this has been done with video gaming. If people find video games very need supportive, that doesn't necessarily affect them unless they have low general needs, in which case they can become absolutely hooked on those video games. So as a first pass of this, we're asking a very simple question. If you find alcohol needs supportive, are you more likely to drink more and be dependent on alcohol? It's a very simple question. So we adapted an SDT scale, we adapted the relationship scale, so instead of when I'm with my partner I feel connected to others, we just ask, when I drink I feel connected to others, and we get people to agree or disagree. And we find largely people agree that alcohol is need supportive, so these ones are agreeing, and they disagree that alcohol is need thwarting. We then did cluster analysis on this, and we found 3 clusters. This green one is just general needs, so this is across the 3 needs: feeling closer, confident, close opinions, free, and confident. This red one's about conformity, so belonging and feeling pressured to drink. And down here we have feel useless and feel alone. So this could either be an exclusion factor or maybe just symptomatic of people who are dependent on alcohol, because an ICD symptom of dependence is you keep drinking even when it makes you feel miserable. So we think that's why these could fall off, and we have a general needs over here. Then we correlated this to alcohol consumption dependence. We find that yes, people who find alcohol needs satisfying are more likely to report greater alcohol consumption and dependence. And in fact, when we control for age, gender, and remoteness...
James, I'm sorry to interrupt, mate.
Yeah.
I don't know if you can hear this, but your mic is muted.
Oh, really? John, I'm not quite sure how to unmute. It's probably the unmute button. Is that better?
Perfect. Much better, thanks, mate.
Sorry guys, you've missed 90%, but let's keep going. If anyone has any questions, please ask me later. Okay, so we found, I'm basically talking about, we're looking at whether basic psychological needs are linked to drinking. If you find alcohol needs satisfying, do you drink more? Are you more likely to be dependent? We found yes, indeed you do. For every standard deviation in finding alcohol needs satisfying, you drink on average 1 standard drink more per day. So this is obviously pretty early in the piece, but we hope to drill down on this more, and Emma, me and Rich have a few additional studies we're going to follow this up with. So, you've actually come in at a great time, because all that information was irrelevant based on why I've been asked to come in. Why am I here? I'm here because I was invited to talk about meta-analysis, and in particular, ASReview. So, what's the point of a systematic review? Well, you try and get all the research on a topic together, and then you bring it together in a meaningful way. And the aims and the advantages of a systematic review is that it should be replicable and transparent. But of course, in reality, that doesn't always pan out. And in particular, this one, how you get all the research for a topic together in a meaningful way, is quite difficult, because there's a tension between including everything and finishing before the inevitable heat death of the universe. And also, the more you include in a systematic review, the more records, the more decisions you make, and the more opportunities there are to make mistakes. So it really is a bit of a nightmare. The 2 steps where you actually bring together, so you can't really afford to read every single paper on a topic, because that would take literally forever, or at least beyond the lifespan of human. So generally what happens, you obtain records which you think might be relevant based on search terms, which are replicable, and then you do a title and abstract screen. But of course, this is still really difficult. I mean, imagine, this is my visual metaphor for how it goes. So you're trying to dig up gold from the ground. The problem is, all the gold is randomly scattered to the ground, and so the only way to get it all is to completely dig up the whole area, which takes ages and is massively destructive to the earth. Don't do it. But imagine if magically the gold could be sorted such that all the good stuff is in the top layer and all the rubbish is at the bottom. Then you actually don't need to dig the whole way down, you just need to dig until you hit Earth reliably. This is basically what ASReview does. It's machine learning for systematic reviews. It's not going to actually collect the gold for you, but it's going to sort them so they're much easier to find. So I'll just point out here, I did not make ASReview. I literally just emailed Phil and said, hey, do you think this looks good? And he said, yes, come do a brown bag in it. These are the people that actually wrote the code. And this is the basic workflow. So you assess a record, this improves a machine learning model on that record, it sorts the publication, and then you continue until you're done. And one of the machine models it uses, you can select different ones, but the default is a naive-based model. So the way this one works is it basically takes all the words from a title and abstract together, it takes them apart, it doesn't worry about word associations or anything clever like that. It takes the records that are in the review and those that aren't, and it figures out the probability for a certain word being representative of a record being included. And then it classifies, it updates the probabilities for each record in your review, and then you get presented with the next most likely to be relevant. So that's that gold shifting to the top. How does it perform? Well, they've done simulation studies with known datasets that you can test around with yourself, and they find that after assessing just 10% of records, you're likely to have found 95% of eligible records. So let's say if you're doing a 20,000 record review, then chances are you're not going to need to go anywhere near through all of them to have all of it. And this means that, at the start of a review, you really should be paying attention when you make something irrelevant, but eventually it's going to get to the point where it's just everything's irrelevant. You can probably smash through it. Or alternatively, you can stop without doing all of it. So you can potentially stop, let's say if you get 100 or 200 misses in a row, it's okay potentially to stop. One of the nice things is it's also super transparent, so you're going to be able to extract a report from your systematic review that you can publish with your paper that shows all your decisions, which is scary because probably some of your decisions were terrible. You don't want people to ever know, but you could potentially do that, and that will increase the transparency of your research. Okay, apparently I'm doing a demonstration now, so I'm going to go to my computer, and I hope you guys following online can see anything. Okay. So the first step in a systematic review is to actually get your data file. So I'm going to go through all of it until we actually do use ASReview. And here I'm going to pedal one of my packages that may help you develop search terms. So it's got a few things in it. I'll show you quickly. It's called keywords, and actually I'll show you super quickly where you can get it. If you go to James Conigrave, GitHub, sorry, I search myself a lot, so it comes up very freely. Honestly, I really struggle to get anything done. Go to your repository, or go to my repository, sorry, you had nothing to do with this. Type in keywords, and then you can get the installation instructions here. So you just take this bit of code, drop it into R, and then it will download it for you. So this one has a few functions in it. The main one we're going to be using here is just search terms, but just to demo quickly, you can make a Prisma diagram, which you can drop straight into an art markdown and other fun stuff like that. But we're using it for search terms. So you can see here, I'm going to demo a systematic review that me, Emma Devine, my supervisors, and Emma Bradshaw / Conigrave did. So this was a systematic review on growth mindset and self-esteem. So you can type into this function search terms, just the terms you want to use for implicit theory. You can say that you want to use stuff like adjacency operators, so this will tell the databases that, for instance, entity has to be within 2 words of theories, which can help you cut down on some publications, because let's say if I was doing entity theories otherwise, you could have entity in the introduction, theories in the discussion, they're totally unrelated, and they'll still be connected as a hit. This will help cut that down. So we just run that code, and it gives us syntax that we can then drop into Ovid, Scopus, and I'll make this a bit bigger if I can. Yeah, you get the raw syntax that you can use to drop into different platforms. So I'm going to use this one into Ovid, and you can see it's converted with my adjacency syntax to the correct one for Ovid. Okay, so we copy that. I think I've got a link to Ovid, so don't waste your time too much. I'm going to go psych info, which doesn't have an H in it, I've learned. Type in my super secret password. And then I can just copy and paste that syntax directly into Ovid, and we should be good to go. So it's in there, search. This is exciting when we test the speed of the internet. So we found 195 records. Okay, so basically from this point, all you've got to do is take these records and get them into EndNote to proceed with the ASReview journey. So we're going to select all, export, and then however you want to get it into EndNote, you can do it. One of the good citation styles is RISC, because you can use it on Zotero, EndNote, all different things. So we'll download that, except I already have, because it takes a while to import into EndNote, so we're going to skip that. So we've got all our records, they're in EndNote. Next thing we're going to do is delete our duplicates. So we just select them all, we go references, find duplicates. It will ask you to click through all of them, but you don't have to, you can just X out of it, and then you've selected all the duplicates, and you can just delete them. Okay, now we're pretty good to go. Now, to get this out of EndNote and into ASReview, you need to export a .ris, which we can do pretty easily in EndNote. So we'll go File, Export. Make sure the output style is on RIS, so you can see Refman RIS export. Then we can just go onto desktop, make sure this is .ris, export it, and then that's exported. So let's have a quick look. You can see here's that file. We can actually open up in Notepad just to look at the structure of it. RIS is a super simple structure. It's just stuff like type, journal, abstract. There's the abstract. And lots of different software can use it, including ASReview. Now, to install ASReview, I'm not going to go in it too much. Basically, you need to download Python, and then you can install it based on the instructions on ASReview's website. So let's just go there quickly. ASReview, GitHub, install. You can then install it using pip install, but yeah, it's kind of annoying if you're not used to installing stuff through the command line, but you definitely can work it out. Once you've got Python installed, you just need to go pip install ASReview, and then you've got it. Okay. So to start it, you need to find your command line. So in Windows, I use the shell because it's blue and pretty. Well, it's probably a bad idea. I don't know if you should use the shell, but I use it. To open the shell, you just go Windows XA. We're in the shell. Then you type in ASReview Oracle. You can see a Python software is working in the background, but it opens up an interface in HTML, basically like a local website, so you can then play with it. I'm just going to delete this one because this is when I was practicing demoing it. So we go down, delete. Need to copy and paste this in. Yes, delete. Okay. Start a new project. There's a nice big plus down here. We go new. I'm calling it demo. My name is James. Description is this is the demo. Create. Then there's a nice button at the top saying start setup. And all we have to do is drag that RIS file into the software. So here it is. Drag it in. Upload. Now it's successfully uploaded all our references into the software, and we can start screening. So you need to give it something to start working with. It's not going to instantly understand what your research question is. So the way you do that is you search for, you give it some relevant documents and then some irrelevant documents. The easiest way to do this is probably just going to EndNote, and you can use the search panel up here to do a pretty good multi-field search. So my systematic review we're doing right now is on implicit theories and self-esteem. So I'm literally just going to go, give me records that have implicit theories and self-esteem in the title spelled correctly. Okay, there's 3. So I'm going to go back in here, bring this to the left, and I'll search for those records. So one's ostracism and aggression. We pull it up, there it is. I click it, they say it's relevant. The next is self-beliefs among students. Grade level and gender differences, that's relevant. And I'll do the third one to make our model a bit better. That's relevant. Okay, now we need to tell it about irrelevant ones. So from here I'll just go back into ASReview. I ask for a random selection of documents, and I have a look to see, does this have anything to do with growth mindset and self-esteem? Commentary, building on a strong foundation of 5 pathways to the next motivational theorizing. Well, it's a commentary, so probably not. I can't see anything relevant there, so I'll say irrelevant. This actually looks relevant. Academic, self-concept, implicit theories of ability and self-regulation, so I'm leaving that. Development of achievement motivation. This again looks irrelevant. Okay, at this point, rather than just doing the whole systematic review in front of you, I'm going to make Emma Bradshaw do it. So do you want to come down? And, okay, just here, you select your classifier, leave it default, that's fine. Finish. So it's now training the model in the background, you can see here. And just click Start Reviewing. So Emma, you're now presenting, just entertain people.
You're supposed to entertain
Okay.
while I do this.
So basically what's going on, as you start sorting between relevant and irrelevant documents, it's updating the probability of each of these words in the title and abstract as being connected to your research question. So you can see here the progress over time. We've got, I think this is 5 in and 3 out. Every time she makes a decision, it should get accurate. Other thing to point out here is, okay, we just got an irrelevant decision. You've got a counter down here of how many irrelevant in a row you've got. So when this hits 100, 200, whenever you want to stop, you can then pull the pin and move on to the next stage of your review. But what you will notice is the more input you give it, the more accurate the suggestions it gives you are. So what you hope and expect is that at the start of your classifying process, you're going to get a lot of hits, and those hits are going to become more and more rare as they're exhausted. And then you can just opt out. So rather than making you do the whole review, I think we can stop there. So we've got 8 in, 6 out, which is pretty good. I mean, generally in a systematic review, you'll have less than 1% being relevant out of your total documents. So to have mostly relevant right now shows that the model is more or less going okay, that she's got some relevant documents coming out. Okay. So the next step is you finished your review, definitely too early, but that's fine. All you need to do is download your results, and you can actually export the entire project and put that up, but we're just going to download the results for now. So we have the option of Excel and CSV. CSV is basically just a simpler version of Excel, and we're not crazy, so we just choose that. And then we get the output. So let's have a look at that. And I'll unscrew this and cancel out. We now have a spreadsheet with all the publications in our systematic review in it, and I'll make this a little bit bigger so you don't go blind. So yeah, you've got the abstract, authors, DOI, and various other pieces of information. You also have your decision. So we have the final included here. These ones are the references that Emma said are in the review. And way down the bottom, we have a bunch of zeros. Everything else is unclassified. So, like I said before, this doesn't actually do the classification for you, it just helps you do it more quickly. So in terms of collaboration, you have the option to, for instance, have one person use this system and then have another person check to see if they've made any errors using this spreadsheet. You can upload it again and redo various bits. But once you're totally happy that you've got everything you need and you want to go to the next step, this is where we go back to the keywords package. So I'm just going to call this something simpler so it's easier to, that's fine actually. So all we do is go back to R, you go keywords, ASReview CSV to RIS. So I give it the path to the CSV output from ASReview, and then all we're going to do is give it a new file name for where I want the RIS converted back to. And when you have the RIS again, it's easy to put it into EndNote and go on as normal. So I'm going to call it this output. Went too far. Output.ris. Okay, so then that should convert the CSV back to a RIS, and you can see we've got output.ris. And then to get into EndNote, so you can see there's quite a few steps, but it really isn't too scary once you get started. I choose the file. I've got it set to reference manager RIS, import, and you can see all the references that Emma selected are now in EndNote, ready to do full text screening. So I'm just going to stop suddenly, that's basically it. Are there any questions? All good. If you've got any questions, you can ask later. Any in the crowd? Yes, Marcus.
Just first off, IT have arranged so they can have that package installed on your computers. You don't have to manually do it and stuff. Instead of flipping it, it happens for you.
That's great.
And second, are you familiar with Radon, which has a machine learning component that's good to see the actual interface, so you can actually see what is being excluded in the actual.
Right. No, I'm not. I am barely familiar with ASReview, unfortunately. But I am familiar there's a few other software solutions being sent around at the moment, and certainly try them all back. If you find one superior than the other, definitely report back. I'm not tied to ASReview at all, but I found it pretty fun so far. Any other questions? Okay, I think we're pretty sold. Anyone from Teams got any questions? What is the keyword package again? So the keyword package is just my R package on GitHub. So again, very briefly, I'll show you how to get it. James Conigrave, GitHub into Google. Go to repository, sorry, I'll go slower. Up the top there's a bar. One of the buttons is repositories. There's just a bunch of code libraries that are on my GitHub. Click that. You can see my resume if you like, but you can also go to keywords. And then you get installation instructions, and you'll get a rundown on some of the functions there. It's also got a nice one. You can give it a path to a PDF, and it will extract keywords from that PDF that might be relevant, which is why it's called keywords. It uses topic modeling to do that. So that's the idea behind that one. Here's the Prisma.
Do you have an associated paper we could reference if we would use that?
It's not associated with a paper. Let me just check to see if I've got a citation. There's a basic citation here if you want to use it. But if you are literally citing it, maybe send me an email and I'll think about how you should cite that. But you'll just be citing a support manual or something like that. What is the difference? I missed that. Trying to find where this question is.
Yeah, I agree.
Does anyone know how to use Teams? I'm trying to find this question. I think, okay, what is the difference between using keyword package and not using the keyword package? Okay, the difference between, well, you'll have a much more entertaining time if you use the keywords package. That's why. Did I show you all those cool functions? I thought they'll speak for themselves, but actually, if you are using, so the first one was the search terms. It can be useful if you don't want to figure out the syntax of all the different databases. That's useful. The second thing that actually is kind of essential if you're using ASReview is your export from ASReview is just a CSV with the files, and there's no direct way to get it back into EndNote, which is why I actually wrote a function yesterday to convert that CSV into RIS so you can get into EndNote and have a smooth flow. So unless you can find another way to get the CSV output from ASReview, which is this one, into EndNote to get you those records back. So any way you can do that, do it. If you can't think of one, try keywords.
There's a 5-minute YouTube video which just shows you just have to alter the titles slightly and then it can be uploaded directly.
Okay, so if you alter the title slightly, because yeah, I know EndNote does have, EndNote's very flexible in getting stuff in, but you will have to tweak the file a little bit. If you can't be bothered, I've done that for you through keywords, but you definitely don't have to use it. Although I encourage you strongly because I wrote it.
So do you publish the ASReview ranking? I haven't seen any publication that uses ASReview. What do you do with those rankings? There's a final column that says...
Yes. You don't have to publish these. So the ones at the top are most likely to be relevant, the ones at the bottom are least likely.
Yep.
You should be going through and manually coding each of these as relevant, which happens in the interface itself. Whenever you click relevant, it gets a 1. Whenever you click irrelevant, it gets a 0. So if you publish this entire CSV, it's going to be very easy for reviewers or readers to go through your rankings and look at the ones at the top and go, well, that was relevant, why did you miss that one?
Yeah.
So it does help, it definitely helps with transparency. Yes?
Do you know, maybe I missed it, but do you have more details on how the algorithm behind the rank works? So does it look at, well, obviously it will look at the appearance of keywords, but does it then add words that often appear together with the keywords, or does it look at the distance between the keywords, or how does it, do you know more?
So this is stretching my knowledge. I know it's called naive Bayes. And generally naive-based classifiers, it doesn't looking at word interactions. So it basically just treats all those words as totally independent observations. It doesn't look at distance, doesn't look at interactions, and just looks, whenever this word comes in, there's like a 30% chance it's relevant. And whenever this word is, it's a 40% irrelevant. And it basically looks at all the words, calculates the probability, it sees if it's more likely to be relevant or not relevant, and uses that probability or likelihood calculation to do the rankings. Is my basic understanding of it, but that's from reading about naive Bayes, not going through source code. I'm not 100% sure how it's been implemented here. Okay, cool. If anyone's got any extra questions, feel free to send me an email, or I'm happy to hop into a Zoom if that's helpful to run you through anything. But yeah, thanks for listening.